Well, recall in the previous video, we talked about a direct linear transformation versus an opposite linear transformation. If it's direct, it would take a triangle and the orientation of the vertices, if it were going clockwise around A, B, C, it would maintain it. That would be direct. An opposite transformation would take the triangle from one direction to the other direction. It's like it flipped it over. Well, our first theorem here on orientation says that if you take the composition of an even number of opposite linear transformations, so remember what an opposite does, it reverses the direction, changes the direction or the orientation. If you take an even number of those, it's going to become a direct transformation. That should be easy to see. It's like taking a triangle, flipping it over. Now it's reversed. Well, if you take that and flip it over again, it puts you back where you started again. So an even number of opposite linear transformations is a direct transformation. The composition of an odd number of opposites, well, that's going to remain opposite. Kind of like taking a negative number, raising it to an even power, changes it to positive. Negative number raised to an odd power maintains its same negative sign. Okay, next one. For a point C, we are going to prove that this reflection about the point, remember SC, S sub C is the reflection about that point. When you apply that twice, it's the identity mapping. In other words, it's exactly where you started. That is, show that for any point P, if you apply the transformation, the reflection transformation, twice, which looks like this, you get exactly what you plugged into it. Same point. Okay, just as a note, a very similar proof would be if you're reflecting about a line. It's also the identity mapping, very similar proof, and PFTS problem for the student could be a test question. So let's take a look. It's very simple. Let's take the point C right here, and then let's draw a point P anywhere we want to. What is the reflection of the point P? We'll call it P prime. About the point C? Well, all you have to do is draw the line segment P prime, forcing C to be the midpoint. Not exactly the midpoint, but let's just pretend like those two lengths are the same. That's all it is. So if you take P and you reflect it about the point C, you get P prime. Well, then what happens if you apply the reflection one more time on P prime? What's the reflection of P prime? Well, it's going to put you exactly back at the point P. That's all that this is saying. By definition of the reflection about the point C, the point C is the midpoint of the line segment P prime. Therefore, it's the midpoint of P prime P because, well, that line segment is exactly the same as that line segment. So, S sub C of the point P is equal to P prime. And then when you apply it to P prime, you're going to get P. Therefore, let's just use a substitution. What is S sub C of P? S sub C of P is P prime. So replace this in parentheses with just P prime. And we already know that SC of P prime is just the point P. So we ended back up with the point P. After applying the reflection twice, we end up with exactly the same point that we started with. From P to P prime, back to P. All right, number 14. Given a point P not on the line L. Well, here's our line L. Let's put a point P somewhere. Say right there. It doesn't have to be there, anywhere you want, but make it fairly close to the line for drawing purposes. Derive a compass straight edge construction for the point P prime being the reflection of the point P around the line L. So it's going to be somewhere around here, the mirror image around the line L. So we're going to actually construct it. So I need my compass, and all I'm going to do is construct a perpendicular from the point P to this line. Remember how to construct it? Make it a little bit longer. Put the point on the point P. Make a notch. Oops, make a notch. And then go over to the other side, make another notch. So this point and this point are equidistant from the point P. Now I'm going to use my compass from this first created point. Oops, draw an arc. Harder than it looks. Draw an arc. And then draw an arc from this one as well. And where they intersect, right here, connect that to the point P and we have our perpendicular. So I'll use a straight edge for that one. Let's see. Okay, so that's our perpendicular. Now we just get this length. We need this point here to be the midpoint of the line segment. Let me make that line a little bit longer. Line segment. Okay, so measure this with your compass. That's about right. And then mark the same distance on the other side of the line L. So this point right here would be P prime. So we officially constructed it. So that length is the same as that length. All right, last example. This one's pretty short and sweet, but it's kind of fun. You can think of miniature golf or even a pool table here, where we have a ball. I really only care about the inside point. And what we want to do is figure out, how would I have to hit this ball? What direction in order to end up in this hole? And by the way, this is an obstacle that the ball can't go through. So it's going to be something like hitting it here, then there, and then going in. So, using geometric construction, locate precisely the point P on the line M where the ball should bounce in order to end up in the hole. Mark the desired path of the ball. So this may be what a pool player does all of the time. So somewhere on this line M, or this wall, if it's a pool table, we need to hit the ball into that. Label the ball as A, and its reflection about the line M as A prime. So that means drop a perpendicular and extend it exactly the same length to get to A prime. I don't need to worry about well, I will. I don't need to worry about drawing the bigger circle around it. Okay. Label the hole as B. That's where we want the ball to end up. And its reflection about the vertical segment as B prime. So let me go this way and drop or raise a vertical. And then go that same distance one more time. Something like that. B prime. Okay, yeah, my lines aren't perfect, but now notice how easy this is going to be. Draw the line segment A prime, B prime, and we are done. A prime, B prime. Let's see. Okay, where that line segment, I may be off just a little bit, where it intersects the line M is where we want to hit. So we would hit the ball. We're gonna kind of draw the mark the desired path of the ball. We're gonna go to here, and it's gonna reflect towards B prime, but it's gonna hit this wall. And then it's gonna reflect to B. And that's how we would make the shot.